To the viewers, now we discuss an important function, dirac-delta function. So at first, let us consider a function delta epsilon x given by the following relation. Delta epsilon x is equal to 0 if x is less than 0 and 1 by epsilon if x is belonging to 0 epsilon and 0 if x greater than epsilon. Now minus infinity to infinity delta epsilon x dx, that will be minus infinity to 0 delta epsilon x dx plus 0 to epsilon delta epsilon x dx plus epsilon to infinity delta epsilon x dx. But if we consider the relationship, first one will be 0 if x less than 0, so it will be 0. Now 0 to epsilon, second one, that is 1 by epsilon into, it will be dx, and third one x greater than epsilon, so it will be 0. So finally we find 1 by epsilon, 0 to epsilon dx. It will be 1 by epsilon into epsilon, so it will be 1. Now here we may consider here delta x as a limiting form of delta epsilon x as epsilon tends to 0. That is, delta epsilon x tends to delta x as epsilon tends to 0. This delta x function is called dirac-delta function. And this dirac-delta function has huge applications in the impulsive force and basically in many parts of the physics and in many parts of the applied mathematics, and it is very, very important. Now we end our discussions, give a short view of Dirac-delta functions and how these functions came from and what actually Dirac-delta function is. If you like this video, like it, share it, subscribe the channel. Thanks for watching.